We're going to talk about the difference between displacement and distance traveled in regards to rate. Okay. We live in lonely little parachute, right? Since it's lonely little parachute, we gotta drive places. Yeah? Who drives to Denver? Yeah, we all go to Denver once in a while, right? Okay. One of the stops along the way is Glenwood Springs, yeah? Okay. Does anybody know these distances? Okay, so we could do 53, and I know that means that this is about 127. If I drive from Parachute to Denver, back to Glenwood, what is my distance traveled? Just 53 plus 127 plus 127, right? That's the distance you've actually driven. Okay. It's 307, is that what somebody said? And these are in miles because we're Americans apparently. What is your displacement? Yeah, somebody said it right. It's only 53 miles. Because your end result is only 53 miles from your original location. You are only displaced by that distance. Sense. So how do I know, how would I note this in calculus terms? Okay. Let me right. This can be written as such. Correct. The only difference is a sign change, right? How do I make something negative positive in that? What's those brackets called? Absolute value. Right. So the difference here in calculus terms is that the distance traveled is going to be an absolute value calculation, and displacement is going to be a regular calculation. Because remember, if we do an integral of a negative area, it subtracts it out, right? If we absolute value that, it makes it positive. So distance traveled will be some integral from T1 to T2. With an absolute value around that function. And the displacement, fortunately, is just a regular old calculation. Makes sense? Because this spot here is negative, but we need it to be positive to calculate our total distance traveled. So, you with me there?
Yes.
I'm right here too.
It's Friday already. Can't stop.
It's not Friday, it's Wednesday. We're still going to get it done.
It's Friday pause.
Let's look at a little more specific example. A particle particle has velocity. What do you notice? The rate, right? The rate function here. And we're going to go to the metric system. Calculate the displacement over 0.6. Displacement is the absolute value or not? No, it's not. Displacement is just a regular old integral. So, and we integrate from 0 to 6. You can write it this way because it's declared up here if you want to shorthand it. Okay. Perfectly legitimate. Then you do your calculations. You want me to run that one through? What's the integral? The antiderivative of this. T to the 4th over 4 minus 10t cubed over 3 plus 12t squared from 0 to 6. I can't stress enough how much it is important to write those nice and neat and organized. Anybody lost? Now plug it in, right? 6 to the 4th over 4 minus 10, 6 cubed, 3 plus 12, 6. Do I need to plug the 0 in? That's 0, right? So don't worry about the 0. It's right there. And then do your math. What's the answer? You're good there. That's your response. But it ends up 36 meters. What? That does happen from time to time. Like these easy ones would be a no calculator problem. But again, I know you have a calculator at your disposal on your homework, but please resist the temptation to use it if you need to practice. Okay. All right. So what's the next one we're going to calculate? Yep. Slow down. Distance traveled. Right? We have an absolute value. Here's the problem. We don't know right now where that function is negative. Some of it is positive, and some of it's negative, right? Probably. So we have to figure out where that happens. Any ideas on how to figure out where velocity is negative? Nope. Points of inflection of what? Yes, you want to know where that is, the position function's decreasing. What do we do with the velocity function to find that? Set it equal to 0. Do a sign analysis, right? Okay, so where is that true? And we'll figure out where velocity is positive or negative. So what was the function? Yeah, take a T out. Factor, you can factor that too, I believe, right? T minus 4, T minus 6. So what are my zeros? Yeah, so T equals 0, 4, and 6. Do we need to worry about out here? The interval is only from 0 to 6, right? So we don't worry about the outside. So what is velocity at 1? Plug it in. Positive or negative? Yep. If you plug in 5, you'll get a negative. So this is where we need the absolute value. What we really have is 0 to 4 v of t plus 4 to 6 absolute value. So that's the negative portion, correct? So how do I deal with this? Because I know this is really easy. For this part, yeah. No, I'm talking about this one. How do I calculate this with an absolute value on it? Now, if I wrote it like this, if I write this, what will my answer be? Positive or negative? Negative, right? Because it's going to give us a negative area. What if I do this? That negative plus. That's how you handle absolute value. Okay, since this answer will be a negative, times a negative makes it an addition problem. And you end up with the distance traveled. Okay. So if you see absolute value in these, you switch the sign. Right. So very, very straightforward method to solve this problem. And you can handle this, right? You can go there. The same integrals, you end up with those numbers there, and you get 148/3. method is distance traveled, find the velocity zeros where it's positive, negative, split it up. That's all we got. I mean, I can show you another one if you want, but this will be the same method. It's up to you guys. Seeing some notes. So you got plenty of time to work here. This won't be due until Friday. I'll be gone tomorrow.
Okay.
Not extravaganza.
Yeah, that's right.
So are we going to have time to work on it tomorrow?
Tomorrow I'm giving you a velocity graph worksheet. And then you'll have probably have time to work on this. Probably. I can't guarantee it based on your workspace, but probably. Yeah. Again, things to remember about the worksheet is the position, velocity, acceleration relationships. You'll be using slope. You'll be using X and Y values. You'll be using area under a curve, initial position. All the stuff we've talked about this year will be in that one sheet. And we will talk about it Friday on my return. Okay. So, thanks. I'm going to go sit down.